Hi guys, and welcome to this video. Today I'm pretty excited. I picked up this Loewe, doesn't matter how you pronounce it, Contur 1470 of Gumtree for free. I had a lot of competition, but I was able to, I got lucky I guess, and I talked to the lady, I gave my number, she called me, and I kind of convinced her that, I was the one she had to give it to. So that was great, but unfortunately it came with a pretty bad issue. I'll go into that in more detail later, and I fixed it, spoiler alert, but yeah, I was so we have a nice working TV now. But just to give you a bit of perspective on this TV, it's a highly sought after TV in Australia. It's one of the best consumer TV you can get around. So it has a E3000 chassis. It's one of the rare Loewes that don't have 100 hertz. It's not that rare, but there are more Loewes in Australia that are 100 hertz than none. It's very good for retro gaming. It's been talked about by a bunch of people before in the last 5-10 years in the context of retro gaming. There's an amazing blog from Scott Hunter. He's from New Zealand, and he mentions that TV multiple times, and I'll link in the description. It's very good stuff. And you also have RGB Rob here from Victoria, who has a bunch of great videos about CRTs, and he praises that TV also for good reason. So just to give you some kind of point of reference, this TV is at the same quality level as what you expect from a PVM 2950. It's not quite as good as a BVM or a high TV line tube 20-inch PVM like a 20L5 or something like that, but it's comparable to the 2950. So I got a TV, put it on my table. As you can see, it's a bit ghetto, but I like to put cardboard under heavy TVs. It allows to protect the surface of the furniture you put it on, but also it allows to slide the TV very easily. Just push the cardboard around and you can rotate or whatever. So I advise doing that when you move TVs around and test them out. And it has beautiful convergence, very sharp all around the tube. Geometry seems fine to me as well. This is raw without any adjustment. This is through RGB SCART with a Mega Drive and the 240p test suite. So very good potential. However, you can't really see it here. I'll move to another picture. But the white is extremely as bluish tint, right? So I tried with different consoles, different cables in RGB, and it was all the same. So I got a little bit worried, and so decided to start troubleshooting this. So the first thing we did, I had a friend, my mate Cameron, coming over, and he has an amazing machine. It's a Sencore, or rebranded Sencore Koning Rejuvenator. So we plugged it in to do a live test and see how were the guns. As you can see here, all three guns test fine. So it's not an issue with that. So we started looking into the service menu. We found some settings that looked promising at first. The cutoff and white. And as you can see, the red value is off from the other two. And if you think about it, cyan, so red, the opposite of red is cyan, not blue. So this is not a blue tint, this is cyan tint. So like, okay, we're onto something. Why is red 199 and the other one's more? So look, this turned out to be the absolute wrong place to look. Changing these values doesn't do anything. If you know more about what these values do and how they work, please post in the comments below. But we started looking somewhere else because I'm sure some of you would have noticed. Look at the white background of the OSD here. It's actually white. So it's not on the output on the side of the TV. It's on the input side of the TV. Before the OSD is muxed in to the RGB amplifiers of the neck board and the tube. So it's before that. So the next step I did was try with composite. And composite is actually white, so it's a problem with the RGB input. So the next thing I did after that was downloading a bunch of service manuals. With those old TVs, you have the scan ones, you have the You have the good quality PDF vector / font ones that you can search, but that are missing some pages. It's all over the place. So I downloaded a bunch of them, and I couldn't find anything that had a nice schematic of the signal board. I found some of it, but it seems to be incomplete. So after 1 hour of looking through the manuals, I decided to just take the board out and look at the board itself and just test things out and just trace the circuit on the board itself first. So traditionally on the RGB line, there's not much going between the SCART head and the jungle, or the video processing chip, whatever chip it's plugged into. There's usually a couple caps in line and some termination resistors, and rarely anything else, sometimes some inductors. So this is what I had to do, but it's kind of time consuming to trace those tiny lines. So here is our SCART port. I put a bit of Sharpie there. That's the red line, this is the green line, this is the blue line. And before I started tracing everything, I measured something simple, which is the termination of these RGB lines on the SCART port. And I found out that green and blue terminated to 75 ohm to ground, so I just used this pin here, and which is expected. However, the red line was reading 50 ohms, so that's off. And as we've established already, that the problem is with the red color being too dim, or not just balanced with the other two, and creating that cyan tint. I thought we're looking in the right direction here, so I started tracing the whole circuit. So follow my lead here with the hand. It goes all the way there, goes under these resistors, goes here, and then basically to these 3 points here. These 3 points are the RGB lines. These 3 pins are what I believe are inductors. So they ground in the middle, and then there's input and output. So past this inductor, we have caps here. Little ceramic caps, mostly 0.1 microfarad. I didn't test, it's not really important for the sake of this. And we had 75 ohm resistors to ground. I removed this SMD one here, and I lost it because it's so small, so I put a normal one there, but that's fine, that's mechanically sound, that's all good. So I removed the 75 ohm resistor thinking it failed and that it was reading 50 ohms. So I was like, okay, let's test that. It tested 75 ohm off circuit. I was like, what the hell, what's going on? So I measured between these 2 points, and I had 150 ohms reading still. So I was like, that doesn't make sense. So I removed the one next door to the green line. That green line has no issues of reading 75 ohms. I measured the resistor. It's a 75 ohm resistor, read 75 ohm, and I measured between these 2 points, and there was nothing, no termination. Okay, so there's something interfering on the red line and causing 150 ohm termination. Now, for those who know resistors in parallel, 150 ohm plus 75 ohm in parallel equals 50 ohm. Okay, so that made sense. So what I did next was remove this inductor to see if there was any difference. There wasn't. So I started tracing further. And unfortunately, I didn't take a picture before I did any of this. This is basically how it is now and how it's working. But here, so as you can see, I stuff up a trace here, removing the inductor. It had very bent pin here, so I had to put a bit of pressure, and that came out. But I was able to solder it to the next point here, so that's fine. That's all not moving. Clean. And there was here a jumper, a zero ohm resistor, just like some of these, this one here. I was jumping to that point and then going all the way here and having another trace. And that's the only one of the 3 colors that did that. So this is a termination cap. So that's the ground plane. We have the trace here, terminates here, and then continues its way all the way up here. There. Then we have a 150 ohm resistor to ground, then goes to that pin with the Sharpie mark there. So that particular pin is pin 44 from the video chip. And if we look at the datasheet, we can see what that pin does. And when I saw what it was, it started making sense. So I pulled the datasheet of this chip and found that on this DIP package, it's pin 44 and it's CIN. So looked at the list of the pins, pin 44, and it's chroma video in. Okay, well that makes sense. So if we look at the pinout for SCART, pin 15 is our red pin, the one that we've been looking at from the start, and we can see that this is S-video in for chroma. So somehow on this TV, both are connected all the time at the same time. I don't know how TVs do that, to switch from these video input and to segregate kind of the circuitry behind. So I'm talking about the termination of required for each. Obviously, it looks like here the S-video requires 150 ohm termination, and the R line on RGB requires 75 ohm. It doesn't make sense to me. That doesn't look like proper design to have those two termination at the same time. Back to our chassis, and by removing this jumper resistor here, we were all good. We were 150 ohm was isolated. We have our 75 ohm termination. I put it back in, and we were golden. Nice, beautiful white picture. No tint, and so I still don't know why it was designed that way. It seems like there's no way to get RGB working correctly. I don't see how this could be enabled, disabled into the menu. My AV1 was clearly set as RGB in the menu, so not noise video, nothing like that. So I don't see how this could ever work. Anyways, if you know more about this kind of circuitry and how it does the switching from both inputs, please comment below. I'd be curious to understand what this was. I'm not too fussed by removing the S-video functionality of this set. I'm happy also to just put a switch later if I ever need S-video. That is not a big problem. I'm just happy that RGB works correctly. So a couple of the things that I did while I was there. Well, actually one thing. There is a video by Global Garage, is also in Australia, about those TVs having 16:9 modes, even though they're 4:3 TVs. And now that we use it for video games, we never need them to switch in 16:9. He highlights that most cables, well, it's not just the cable's fault. Is most old console only output 5 volts. They don't have 12 volts, and those TVs, they require 12 volts to switch to the right aspect ratio. If you feed them 5 volts, they'll auto switch to the RGB input, but they'll display it in 16:9, and this is frustrating. So we can see here the status and aspect ratio. If you don't feed any voltage, it's off. It's gonna just be user set. But if you put 5 volts, it goes on 16:9 and 9 volt 4:3. So this particular TV here doesn't have any auto switching. I've set it, I'll show you how, but I've set it to just turn on to RGB every time, because that's all I'm using it for, so that's all good. So there's no really any point to have that voltage sense pin enabled or active. So I took pin 8, which is this guy here, and I severed that trace at this level. I severed it here because you got kind of meat on both sides, and if I need to restore it, I can do that easily. So after doing that, no more switching to 16:9, and we're golden. You may have noticed earlier that somebody actually snapped the cutoff for the second SCART port. This TV has only one SCART port and none of the other options like audio out, anything like that. So it's pretty ugly. I mean, you don't see it often, but while I had the back cover off, I decided to glue a little piece of black cardboard just to, you know, close it off. It is what it is, but, you know, I guess it's a little bit better. One last thing I wanted to mention is how to configure RGB to turn on automatically. As we talked about before, there's no auto sensing that switches the channels to RGB when you plug in SCART. So what you can do is have it just boot up from cold boot straight into RGB. For this, you have to go in the channel menu. That's a bit counterintuitive because, you know, it is AV after all, but you basically go into the same menu that you would tune, so it's station, and then you go into search and store, and that's where you can edit any of the channels to be set to one of the AV sources. And the TV will turn on to the channel that it was last on, even if you power it off from the wall, I believe. So I just set it channel 0 to RGB. I named it RGB, and from that point on, it only boots to RGB. So that's it, guys. The picture is absolutely fantastic. Is one of my best TVs. Really stoked to have that, and you know, it has that arcade feel, very close to what you would have from a good Nene chassis on an Astro City or something like that. And sorry, I don't have a camera that has shutter speed still, so it's flickering, but believe me, it is really, really good. Thanks for watching. If you have any questions, post down below. I hope you found it useful in some way, and I'll catch you next time.